Here we have the program from the last episode where we used the Bezier curve for the first time. And this is the result we get when we run the program. In this program, we don't have a setup or a draw function, so it's not animated. Let's convert it into an animation. So I'm gonna add here a void setup. I'm gonna indent these 4 lines and I'm going to create a draw function. And I'm gonna press Ctrl T to insert some spaces here. Okay, so we just added the setup and the draw. We should add a background call to our draw function, otherwise it will get darker and darker and will never erase anything. So what happens now? So this is quite crazy. I think it's very interesting because there is one part which is fixed, this bottom center part, and then the rest of the image is totally random. So it's really interesting. What would happen if we convert these random calls into noise calls? We know that the numbers we get back from the random function are always unrelated to previous values we got. But with the noise function, we can get numbers which are similar, which are only changing slightly. So let's go ahead and type here noise, and we replace all these random calls by noise calls. But we know that the parameters are a bit different. We know that noise returns a number between 0 and 1, and then we have to multiply the value we get by this number here. So if we multiply this number between 0 and 1 times the height, we will get a number between 0 and the height. We do the same with the other calls here. Noise times width, noise times width, and the same for these height values. And now we need something more. We need to add 1 or more parameters to the noise function. We know it can take up to 3. What happens if we just enter here some random numbers like 1, 2, 3, 4, and 5? I don't think it's going to be very interesting. And what's happening is not very interesting because on one hand, we are drawing 30 lines, but we are using the exact same values for each of those 30 lines. So we always get the same exact line 30 times. And that's quite boring. If we run the program, then we get a different one, but just one. Is not changing over time and is not changing between different calls to the Bezier function. So one way to get different values here for each of the calls to the Bezier is maybe to add this I value as a parameter. That's one thing that for sure is changing between one call and the next. When we call Bezier for the first time, I is 0. The next time I is 1. The next time is I is 2. So I can add here a parameter, comma I. I'm going to do this for all of them. And let's run the program. Now the result is quite similar to our original program where we didn't have an animation. Here we also don't have an animation because why not? We are not getting different images because every time we call draw, we are sending the same exact parameters to all of our lines. So when we're drawing the first line, here we have 1, 0, 2, 0, 3, 0, 4, 0, and 5, 0. The next line will get I, 1, 1, 2, 1, 3, 1. The next line will have 1, 2, 2, 2, 3, 2. But the next time we call the draw function, we're drawing again exactly the same 30 lines. There is no parameter which changes between one draw and the next draw. So we can add one more parameter. And what parameter could we add? One number we know that changes is the frame count variable. We know that this is for sure changing between one call to the draw function and the next one. So when the program starts, this variable is 0, then the next time draw is called, it will be 1, then 2, 3. So let's add this to all of our noise calls here. So we're having now 3 parameters on each. The first parameter we are using to make each of these calls different. So we use here 1, 2, 3, 4, 5. So then we avoid having the same number between these 5 calls to the noise function. Then we are adding another parameter, which is I. With that, we avoid having the same values between one Bezier call and the next Bezier call. So we're drawing 30. They should all be different. That's why we add the I parameter. Finally, we are adding a third parameter to avoid having always the same 30 lines between one call to the draw function and the next draw. So we have a value that changes each time we call draw. We have a value that changes for each line, and we have another value which changes between all these different calls to the noise function. Let's see what do we get now. Okay, so this is again changing very fast. It's similar to when we had the random function. Why is that? Frame count is changing too fast for what we want to achieve. So what I'm going to do is I'm going to declare a variable here, float t. I'm going to say here frame count divided by 100, for example. And then I'm going to replace all these variables here, these frame counts. So here t, t, t for each of these. And we saw in the last episode, we should convert this to a float. Otherwise, it's not going to be very interesting if I run the program, because this is an integer and this is another integer. Then the result is an integer which changes very slowly. One solution we saw in the last episode is to add here a float around this. But there is one simpler way. We can just add here a .0, for example. When we make this number a float value, and it is a float value because it has decimals, then the whole division will be a float value, and now we will get the nice effect we want to get. How can we control the speed of this motion? So if this number is smaller, for example, now I try with 50, t will be changing faster. Okay, let me explain it in another way. If we have just frame count here, we know this is going to be 0, then 1, then 2, then 3. If I divide this by 10, t will have other values. It will have values like 0, 0,1, 0,2, 0,3. If I divide it by 100, I will have 0,01, 0,02. So you can see the steps are much smaller. If I try here with 1000, and now it's moving really slow. And if I want to try faster, then I can try with 10. Well, 10 is definitely too fast. We can try with other values, maybe 50. Well, 50 is kind of okay. So the trick is to have the objects move more or less between frame and frame. And actually, in this case, we are controlling this with the variable t. We could consider the variable t like our time, because we are using it to generate random numbers. If t increases in big steps, then the random numbers are very different between calls to the draw function. If t increases in very small steps, then the noise values we get on one frame will be quite similar to the values we will get on the next frame. So now we have created our first animation using Bezier curves.